Okay, so in this video, we're going to go through this question here. So have a read. So a group contains the elements A, B, C, and D, where we've got our binary operation represented by the asterisk. And given that A is the inverse of B and A squared equals C, we need to complete this Cayley table, which does have one element filled out in the inside. Okay, so you might want to pause the video and have a go, see how you can do. But if you're stuck, then start watching. And if at any point you think, okay, right, I know how to do this, then pause the video again and have a go. So we're told it's a group, so that means we can use all the axioms of the group. It must be true. We know that this Cayley table must be a Latin square. That means each element must appear exactly once in each row and column. So we're going to make use of that too. Okay, so let's start going through the information. So we are told that A is the inverse of B. So that means A combined with B is equal to the identity, and B combined with A also equals the identity. However, I don't know the identity yet. Okay, so I can't actually fill anything out, so we'll come back to that. We're also told that A squared is equal to C, so that means A combined with A is equal to C, so therefore I could pop a C in there. Then it says complete the Cayley table, so let's look into the Cayley table, and we've been told that D combined with D is equal to D in the table. Now, this is actually telling us a very important bit of information, okay, because we've started with D, we've combined it with some element, and we're still getting D at the end. So therefore, D must be our identity. Okay, that's the only way this could work. Okay, so that means now we can go back, and if A combined with B is our identity, then A combined with B is D, and B combined with A is also D. So we can fill those in there. Now, also, if D is the identity, then we know that D combined with A is going to be A, D combined with B will be B, and so on. This is going to be C, so we can fill out that row, and we can also fill out the column for D. Okay, it's just going to be A, B, and then C like that. Okay, so we've got a lot filled in from that. Now, a good thing once you've got a few things filled in is, look, is there any row or column where there's only one element missing? Because then we can use the Latin square property. So if we look in the very first column, there's an A, there's a C, there's a D. So that means there's a B missing. So we must have a B here. Okay, and then in the top row, we've got a C, a D, and an A. So once again, there's a B missing, so we can fill that in as well. Okay. Now we've got rows and columns with more than one element missing. Okay, so one thing maybe you should consider is, what are the inverses of the elements? We know the A is the inverse of B, B is the inverse of A. So we got the A and B inverses sorted. If D is the identity, then it's self-inverse. Okay, now C must have a unique inverse, and the only option left is C itself. So therefore, C combined with C must give us our identity. It must also be self-inverse. Okay, so C combined with C must be D. Okay, and now we should be able to fill out the rest using the Latin square property. So if we look in the column for C, we're only missing A. If we look in the row for B, we're only missing C. And if we look in the row for C, we are only missing A. Okay, and there is my Cayley table complete.